Okay, done. So now it is recording. So as I posted in the group just now, um, not in the chat box here, but in the main group, I posted one question because I believe that one question, is it Madagascar? I'm not even sure what the place is. I just put it because it's nice. Anyways, so I believe because that one question will be able to recap back the whole thing about line integral. We know that there are two ways. Can I say two ways? Yeah. Two scenarios of you doing line integral. One is given an integral and given a line, you can integrate the function with respect to that line. Another scenario is when you have a bunch of lines and these lines form a closed loop or a closed region. In that case, you can either do it directly, which will be a bit long, or you can actually shorten the time taken by using Green's theorem. Because whenever you have a loop there, you can use Green's theorem. So here's what I'm going to do. We are going to be in this meeting, okay? I'm going to be online, but I want you guys to try out the question by your own. You can refer back to the lecture video or the whiteboard. Maybe the whiteboard is enough. You don't have to look back at the whole lecture video. Try out part A and part B. Okay, let me look at the question. Let me share the screen. Okay, how do I go there? Okay, so this question right here. Okay, so you have a closed region, obviously. Okay, you have a closed loop, and therefore there are two ways to find the integral here with respect to the whole combination of lines. One is you can use Green's theorem. Okay, that would be the easier way, part B. Part A would be slightly hard because you have three lines forming the region here. So let's say this is line 1, let's say this is line 2, and this is line 3, for example. So you have to integrate this expression with respect to this line. That's one answer. With respect to this line, the second answer. With respect to this line, the third answer. And you have to add all answers together. Then you will have the final sum as the integral along the combination of three lines. You should get the same answer for A and for part B. If you get it, it means that Green's theorem is correct. Indeed, you can do it two ways, either directly or by using the theorem. So that's the whole aim for us today, to prove that indeed Green theorem works. So take your time, take a piece of paper, try out part A and part B. I will be here online at any point. If you have any questions, feel free to ask me. Okay, this is not a test. So to make sure you're not stuck at any point, feel free to ask any questions. But otherwise, so I'm going to leave it to you. Try out this question right here. You want to download it, you want to view it here, up to you. Okay, so try it out. Just let me know if anything. So meanwhile, I'll get my whiteboard ready here. So we'll discuss it when more or less everyone is done. Maybe part A first or part B first, okay? Just try it out, try it out. I've also done it in my paper here. We'll discuss it in a while. Please refer to the whiteboard first before you give up, okay? Refer to the whiteboard. If you're still stuck, then let me know here. as usual, not as usual, but as in the previous class, if you are done, just snap a picture of what you have done here. Okay, previously, I did it for this class, right? I'm not sure whether this or another class, but I created a OneDrive and you can upload your answers in the OneDrive. Let me share the link here. So if you click on this link, you will come across a folder. Inside the folder, create another folder by typing your name, so I know that that folder belongs to you, and upload your solutions into there. Let me know if it's not clear. Yes, Lee, correct. The range is always 0 to 1. Yep. So when you do the parametric equation, the vector equation, the t is always 0 to 1. Okay, welcome. So I see some of you have already created a folder in the group. Don't forget to upload your solutions into there. You must get the same answer for part A and part B because those are just two different ways of solving the same thing. So just be sure on that. How do you find the y range for Green's theorem? Okay, let me look at the question. Let me share my screen, Lee. Okay, so this was the diagram given in the question. Now for Green's theorem, obviously you need the region inside the triangle, right? So okay, how can we find it? Let me write down the coordinates that we have. So here you have a, oops, it's too big. I should drag this a bit more. Give me a time. Okay, so here's the origin coordinate 0, 0, and here's there's negative 3, 0, and this coordinate is 0, 3. So the x is quite easy to find out. The x is from negative 3 until 0. The y, however, is from down here until the line here, from here until here, here until here. So the line down here is easy. It's y is equal to 0, right? This is y is equal to 2, y is equal to 1, this is y is equal to 0. So we know that the lower bound is easy, but the upper bound is this line. The equation of the line is not given. However, when you know the two coordinates of a line, you can find out what is the equation of the line. Y is equal to mx plus c. So another way that I usually do is this, y1 minus y, y minus y1 is equal to gradient x minus x1. I usually use this. So in this case, let's say I pick this coordinate, okay? So y minus 3 is equal to the gradient. Okay, let's compute the gradient. 3 minus 0 divided by 0 minus negative 3. Okay, that's the gradient. And then x minus x1, the coordinate that I choose, it's 0. So solving this, y minus 3, 3 divided by 3 is 1, 1 times x is x. So y is equal to x plus 3. That is the equation of this line. So now that you know the equation of the line, you know that the upper bound is x plus 3. Was that clearly? Was it confusing? Okay, nice. No problem, Lee. Which part, Tanish? Which part that you quite don't understand? Like how to get... You do understand the coordinates, right? I just took it from the diagram. I just read the coordinates. 0, 0, 0, 3, negative 3, 0. That part, are you clear? Or the coordinate itself is... Okay, that part you are clear. So now I want to know what is the lower limit and the upper limit of my y. So my lower limit is this, because when I look at the y, it always starts from this line until the line up here. This line until the line up here. So the lower limit, I know this is it. This is y is equal to 0. So that one, clear. The upper bound, however, is not so clear because the equation of this line is not given. I have to find it out myself. So because of that, one way to do it is this. In fact, this is the way that I usually do when I want to find the equation of a line. When you know two coordinates of a line, just plug it in into here. Your y1 and x1 is one of the coordinates that you choose. So you can choose this, but I chose this just now. No problem with that. As long as it is a point that lies on the line. So y is just y. y1 is the y point here, which is 3. Okay, equal to m. Let's leave m for the moment. X minus x1. x1 is the x coordinate here, so 0. The m here is the gradient of the line. How do you find the gradient of the line? You have the formula y2 minus y1 over x2 minus x1. So in this case, 3 minus 0 over 0 minus negative 3. So then I got the gradient. So this whole thing, if you compute, is just equal to 1. So y minus 3 is equal to 1 times x. So from here, I get this equation. If you don't know how to find the equation of a straight line when you know the 2 points, just use this. This is a standard way. Okay, nice. So by the way, if you are doing this and you are unsure whether you are getting the right answer or not, using both methods, I get the answer was 99 over 4. Okay, using Green's theorem or using directly, you should get 99 over 4. The rest of you, if you have any questions, make sure that you ask. Otherwise, I'm just assuming that you know, but you are taking your time. So I'm just writing for the first part, part A, right? Because you have to do it separately. So for each of the line, you have to find your RT, you have to find your R prime T, because you need it back to substitute into this integral. So I'm just going to write the RT that I got. By RT, I mean the parametric equation. So I'm skipping some steps here. Of course, the initial step is like 1 minus T times the initial point plus T times the end point. So that is where I got this. It means we can choose either one of the line. I mean, because if you want to find the total integral, no matter how you assign your line, maybe your number one is this, maybe your number two is this, doesn't matter. At the end of the day, you're going to add them all together. So the order in which you choose the line doesn't really matter. You're just going to add them all together, do them separately, and add all three answers. But if you use Green's theorem, then that's a different story altogether. You don't even look at the lines. For Green's theorem, you look at the area inside the region. So that's a different story altogether. So maybe your assignation of 1, 2, 3 to your lines is different from mine. But nevertheless, the parametric equation should have been the same. The order might be different. So for example, if I want to find the integral with respect to line 1, maybe it will be something like this. The original question was Okay, so there's a bunch of x and y in the original question. I'm going to change every single x and y into this. Okay, right now I'm doing for line 1. So this is my x and this is my y. This is my dx and this is my dy. Okay, so let me just substitute into the question to see what I get. This is just for line 1, by the way, just to show an example. And it's 0 to 1 because t is always from 0 to 1. Okay, so for example, for line number 1, I get the answer is -3. So I do the same process for line number 2. This one I got -3. For line number 2, I got 75/4. So for line number 3, I do the same process again, I get the answer is 9. So adding all three numbers is what give me 99/4 at the end here. So it's like 3 times the work. You find each of the integrals separately and then add them. So Green's theorem, you just do it one shot. But now in Green's theorem, you have to find the region. Okay, instead of looking at the lines, you try to describe the region inside the triangle here. So then the way to describe it is like x from here to here, y is from here to here. So two different ways of approaching the same problem. And I just see that the time is already 12:55. Okay, let me see how many of you actually is a few of you have already uploaded, some of you haven't uploaded. I understand that you might need more time because it's a long question. Okay, here's the deal. Just upload whatever that you have done for the moment. You can complete it later on, but for your attendance, I just want to see who have done at least something. So no worries if it is incomplete. Maybe you have just done the first part, maybe just half of it, no problem. Just upload it here, and after class, when you have time, just try to complete it when you have time, okay? So make sure you upload it here. Can you show the working for line number 3? Let me look at line number 3. Okay, this part, line number 2 should be the hardest actually, but if you want to know line number 3, yeah, why not? So, putting into here, get line number 3. X times y square plus x square. Okay, actually there should be another side here, but then at the end of the day, I see that my dy is 0. So I multiply with 0, the whole right hand side will just disappear. Okay, of course I have a bunch of things here, but then multiply with 0, whole thing disappears. So not going to write that. Doesn't have anything. This part though, this again, the whole thing becomes 0. This, if you expand it, you will get minus 80. Sorry. And I put in my 1 and 0, so therefore I got 9 for this. What is it, Harish? My working has mistakes as I forgot to multiply the derived value in multiply. Oh, this number here. I see. Okay, okay. That is the whole point of actually finding r prime. The r is to substitute whatever that is inside here. The r prime is to get the value that you're going to multiply here. It's okay, it's okay. Just make sure that in the future when you do the same type of questions, you get that thing in here. Okay, just remember there's a point why you are finding r prime. This is the point. Okay, I can see more things are being uploaded. Some folders are empty, but no worries, just upload the thing that you have done. It's okay if it's not complete, okay? I just want to see who have done something. Anyways, it is already 1 p.m. I don't want to take any longer. So try out this one question, make sure you're able to do it. I will share the solution in a while, so you can check out later. Final answer for line 2, I got it was 75 over 4. Line 2, right? 75 over 4. Okay, so that's it. We are done with the tutorial. For your coming lecture, I want to teach something new, and also that is going to be a new chapter. So let's finish up chapter 2. Chapter 2 we have been revising and revising. Let's end it up. Next week, let's have our class test 2 during our second class so that you have more time for preparation, okay, whichever comes late. But next week, class test 2, only chapter 2, vector calculus. Recall back what are the things we have learned. We have learned gradient vector, directional derivative, divergence, curl. Next week is midsem break. Okay, I did not see that, so the week after that then. Okay, okay, my goodness, so many people are reminding me. Sorry, I did not check the course schedule because I have a bunch of classes I'm teaching. I kind of lose track of them all. Okay, if it's midsem break, then after the midsem break, immediately. Okay, so you have time during the midsem break. We'll do the class test, only chapter 2. And of course, after the divergence curl, you have line integral and you have Green's theorem. That's that. Okay, so no chapter 1 and no new chapters, just chapter 2. Okay, so that's that. Let me stop sharing and stop the recording. If you're still uploading, take your